Hey, good afternoon, everyone. My name is Nick Doty, and I'm one of the new software engineers on the ESDIS project. I just started with NASA and with the project in April of this year, so there's a good chance we haven't met, and if that's the case, hello, it's nice to meet you. I just wanted to take a couple of minutes today and talk about what I kind of struggled with the title for, but what I ended up going with is the gotchas of cloud optimized data. And if there's anything that you take away from this, it's that keep in mind that when using a lot of these technologies, a lot of them are relatively new, especially compared to their counterparts, and you're bound to run into some little things that I call gotchas, things that you don't necessarily expect that aren't operating the way that you would think that they would. And so when working with this data, just keep that in mind, that if something comes up and it doesn't seem like it's behaving like you expect, or something seems weird, it might not necessarily be you. It might be something that's going on behind the scenes. A lot of this stuff hasn't necessarily matured yet, but we're getting there. And so with that, I'd just like to give you a couple examples of what's going on. And so what I have here is just a really short Jupyter notebook that will go over quickly two examples that I know in the previous talk that just took place, Amy was talking about the MUR SST data, specifically the one from the AWS registry. And so I've got that pulled up here, and that's actually the same data set that I'm going to look at quickly. And so the thing I want you to focus on is the right-hand side. Now, if you look, there are two versions of this data. Namely, there's one called ZAR, and there's one called ZAR V1. And as far as this page goes, the only thing that you can really discern from this is that they are chunked differently. But from my understanding, the ZAR V1 is the very first version of this data, and that is the ZAR rechunker running on top of the original NetCDF4 data. And then the ZAR data is actually the rechunker run again on the ZAR V1 data. And so as an end user, I would expect that these would operate similarly, that I would get the same output. And what I'm going to show is that that might not necessarily be the case. And so if you're not familiar with the MUR SST data, it's showing that the temperature over the ocean. And so if you've got points sitting over land, you're not going to be seeing temperatures. They should come up as not a number, or some way to discern that it's not a temperature, you're not working on water, okay? And so I've already run everything in this Jupyter notebook just to save time, so I've only got 5 minutes, but I'm working on the date January 20th of 2018, which is available for both of these data sets. And in this first one, I'm just going to go ahead and get the S3 data from the ZAR V1, and I'm going to slice it across a very small sample, namely one that will cover a couple of points on land and a couple points on water. And if we see the output here, we have not a number, not a number, not a number, and then a whole bunch of temperatures. And those temperatures all seem valid, and we get these not a numbers, which is what we expect. Now, if we repeat that same process on just the ZAR data and look at the output, now we see that we're getting these values 265, whereas the numerical values of the temperatures are the same. This isn't something that I'd expect to take place. I would expect them to be the same, and we would hope that our data that we're sharing with the end user is consistent. And so just as a double check, instead of using the S3 link, I use the HTTPS link for the ZAR V1. We do get the not a numbers. This link does not exist for the ZAR data, but so, the question becomes, what's going on here? And so what we've discerned, because we can't access the metadata, or at least I haven't been able to access the metadata of the ZAR values, is that what's happening is that the fill value isn't behaving as we expect. And so this is just a kind of a chunk of looking at that metadata values, and what we've pulled out of there is that given this scale factor, this offset, and this fill value, if you multiply the fill value, the scale factor, and add the offset, you get this 265 value, which is the number that we were seeing above. So that's kind of showcasing how we have two data sets that we would expect to be the same that aren't. Another one that's not exactly related to data, but is something that came up while we were looking through, is when playing around with like a test data set, we noticed that, and if you run the example above, you'll notice this. When you slice across things, you don't necessarily get the number of results back that you want. And the question becomes again, why is that? And if you look, when we just open up this data set and look at the latitude, we get this data type as a float 32. But as soon as we start using Xarray to open this, we notice that not only are they float 64s, but now those values have changed. And although this isn't something that's in our control, but as these data sets become easier to use and access, we expect people might use this slice mechanism to access data. And if they're having these issues accessing information and getting back consistent results, it might push them away from doing that. And so my 5 minutes are up, but if anybody has any questions or wants to see this, feel free to email me, Slack message me. I'm happy to share it. But I hope you've seen how that some of these newer technologies are really great and really awesome to use, but you just have to be mindful of how they operate and make sure that when you're accessing them that you're getting the results that you want. Hope you guys enjoy the rest of the talk. Thanks.